Hello, fellow Haskellers, and welcome to Baba is You. No, not Baba is You, Giggles is You. I'm re-implementing Baba is You in Haskell. I am not. Yeah, Giggles. Blah, blah, blah. All right, so in the last episode, I simplified the code for the movement system. Previously, we had this complex system where we had a chunking system. If we had several characters next to each other that were all you, I wanted them all to move at the same time. And I realized I didn't need that. And at the end of the stream, I realized that I did need that. So unfortunately, I can't just undo because I need it for a different reason. I don't need it for regular movement, but I do need it in order to implement the push verb, which is what I've been working towards for the last several streams. So getting there, getting there. But before getting there, let me show you a few changes I did off stream. So first of all, while I was editing the last two episodes, I realized I made a very silly mistake. Here, the opposite of west is east, not west, and that was causing one of the weird bugs that I had encountered, that when I was moving onto obstacles from the right, I was able to walk on top of them, but not from the other three directions. That was very silly. And then I went on to, while trying to fix this bug, I went on to find a completely separate bug and fix it. So at least I did fix a real bug. I did not waste too much time. And what is this? Right, so I agonized for a long time about the name of this data type. I really did not like the name active, but it was the best I could come up with. Eventually I switched it to active cell, while it was still about a particular cell, namely like all of the entities that are you instead of a particular cell. I want to keep track of those cells so that when I know what are the cells that are part of a chunk that are moving, I can move all of the entities within those cells that are you. And now that I want to introduce push, I need to be more discriminating, because not all of the elements that are you or push will be moving. If there's something here that is push, it will be pushed towards the right if those two are you, but not if those two are push, in which case only this one will move to the right if this one is you. Wait, no, that would happen even if we move all of these things that are you over push. That's only a matter of whether we include all four in the chunk or not. In fact, that's why we need chunks again. But if there are on top of each other, again, those three are pushes, things that are push, and this one is a thing that is you. If it's here, I want it to move this one to the right. But if it's here, I don't want it to move anything. And in those two cases, the thing that is push, that is on the same cell as the thing that is you, is not moving. So that's why I need to be more discriminating than just moving all of the things that are you and all of the things that are push. And so when I moved towards that, I changed the definition of active cell to just be a position pointing at a cell, to a position and a predicate indicating which of the entities I want to move. And so I renamed that from active cell to active entity. And what I did off screen is that I changed my mind again. I want to name this again active cell, because I am talking about a cell. I'm talking about a number of entities on that cell that are moving. I'm not talking about a specific entity. This predicate could select more than one. In particular, if there's more than one thing that is you, or more than one thing that is push, that is being pushed, that are all stacked on top of each other and are being pushed at the same time. So that's it, just renaming, and that's it. So let's just continue. I now want to reintroduce chunking, and the reason for that, as I was explaining before, like maybe there's like those three are things that are push, and this one is a thing that is you, and it's moving towards the right, in which case there's just a chunk of one, or if it's here, same thing, chunk of one, or here, now there's a chunk of 2. Those 2 are moving towards the right, but those two are staying where they are. And that means that I cannot just use the current system in which I go through all of the cells from right to left in the opposite direction of the movement in order to decide once and for all, as I traverse through a particular cell, once I encounter it, I can decide whether it can move or not, definitely. Because if, in this case, right, this thing is push, so I encounter it first before I encounter the thing that is you, and so I don't yet know if it's going to move to the right. Because if everything else on the left is all things that are push and nothing is you, then it won't be moving. So that's why I need to reintroduce the concept of chunking to accumulate information. Okay, I've encountered 1 thing, 2 things, 3 things that are push, and then finally a thing that is you, so all of them are going to be part of a chunk that is going to move. So that means I need to go back to returning a list of cells. I think I gave it the name chunk. So chunk is a list of active cells. So now level chunks and row chunks. Return a list of chunks. That is a list of active cells instead of a list of active cells. And level chunks, chunk, and I need move chunk. So now this is a list, so there's more active cells here. That is, there's a chunk, the rest of the chunk. Yeah, just active cells, plural. We have a list of them. And I'm matching on the level, because I don't think I can be point free here. I'm calling move threads 2, and then I am this, then I like this left to right composition slightly better. Wait. This is not composition. I think I need to use do notation. Okay, so move sprite 2 will give me a level prime. Come on, level prime. And then I can call move chunk on the rest of the active cells. So something else is referring to active cells. It's called move chunks. And indeed, I now want to be returning chunks. So here I'm returning a list of chunks. Okay, so if I have reached the end of the list, what if I already have a chunk that I don't yet know if it's going to move? Well, if I've reached the end of the row, it means that I have, like if I was still uncertain about whether they're going to move or not, then now that I'm encountering a lack of cells, that is, there is not something that is you here to move the whole thing, and so I do not want to include that chunk, so I do well to ignore, well, not this bool, I need the bool and a chunk, so let's start it with an 81. Okay, so I ignore both the boolean and the chunk, and now what's this other case? So if it's true, the bool indicates whether movement is blocked in the direction of travel. No, I guess direction here was clear about whether it's me traveling down the list of cells in order to construct a chunk, or if the direction of movement is the direction in which the character is moving. the direction in which the characters are moving. Okay, so if it is blocked, then again I want to drop the chunk, which I don't yet know if it should move or not, because I now know that it's not move. No. The true indicates whether movement is blocked towards the right. So in that case, I know that the current cell is not going to be moving towards the right, so I'm not going to create a new chunk, but the chunk that was there might move towards the right if on the current position there is something that is U. Wait, no, because if there's a thing that is U, it is not going to be able to move right because it's blocked on the right, so it's not going to be able to move. So I get the impression that I can solve my Boolean blindness issue here. I was slightly concerned about using a Boolean as opposed to using something like a maybe, where I can distinguish at the type level, not at the type level. The type system can better help me to distinguish between the true and false cases, because in the true case, I also have access to an extra value because I'm representing it as just of something, and like if I arrange things such that in the true case I need to have access to that thing, then when I try to access that thing on a nothing, then well, I don't have the thing. It's a scope error. So that leads me to use the Boolean correctly. So I think I can use a maybe chunk here if maybe I swap the meaning. So nothing means the movement is blocked in the direction in which the characters are moving. Okay, so if we reach the end, then it doesn't matter if it's true that it is in the nothing case, because I've decided to represent the blocked case as nothing. I don't have a chunk and I don't need a chunk because I'm not adding it, because if things are blocked, I already know that the chunk is not in both. Excellent. So I recur. Well, now I have this extra argument that used to be a Boolean. Now has stops is a Boolean, so I need to convert it into the appropriate representation. So if there are stops, if there are things that are stopped in the current position, it means that I'm not starting a new chunk. Nothing's going to be able to move onto the current position. So it's still nothing. Otherwise, I can maybe begin an empty chunk. Because I need to adjust in order to represent the fact that we are not being blocked. But I don't yet have anything that is going to be moving, like the current cell. The things in the current cell are not going to be moving because they are blocked by whatever is on the right. But something could be moving on top of this cell if nothing is stopped in this cell. Okay, next. So false, that's the case in which we are not blocked, so that now corresponds in this new representation as just of a chunk. Do we need a reverse chunk this time? Since we are traversing from right to left, if I cons each time I encounter a new thing, it means that the chunk would be in the order in which we're moving all the way to the right, which has caused problem in the past, and I've reversed the chunk. I guess I just need to do that again. I don't think there's any need to store them as reversed here. Just maybe we need to reverse them when we try to move them. because remember, like there was this bug where if I was moving this here and then this here, and moving all three on top of each other instead of what I actually want to do, which is to move this one here and this one here and this one here. So that's why it matters whether I start from here or from here. Anyway, so in the case in which there is a chunk and it can move to the right because it's not blocked, then I look at the current cell to see if there are any things that are use, okay, and if so, then the use and the entire chunk is moving to the right. So here, instead of just active cell, I want to add active cell on top of the chunk, which is inside of the just. And here, same thing. If there are things that are stopping further things further on the left from moving onto the cell, that is things that are stopped but are not you, because the things that are you, they've just moved out, they're not blocking you, then thing otherwise, well, I've just outputted the things on this cell that are being moved out. So do I want to include anything here? Because I know it's going to be a just, I'm just not sure if it's going to be the current, like empty, or the current cell. This is getting pretty long. So like this. Okay, so let's see. So is there a case in which there are things in the current cell? It's not the use, because the use have moved away already. It's not the stops, because the stops are not moving. But here we have established, since we're in the else branch, that there are no things that are stopped. There might be things that are pushes. So let's include in the current cell, in the chunk, let's include the current cell. So active cell of the current position and is push rules. That's the criterion I want to use about which things are now going to be part of the chunk. Yeah, I think that covers everything. I was just briefly wondering if I should include the things that are push here, and I guess not, because they are included here. I don't want to double include them. And in fact, I wouldn't want to include them in the first place, because here, since it's before the con, it's the thing that I am now convinced I know they are moving, and the things that are pushed I don't yet know if they're moving. Okay. So otherwise, so if there are no U's to power the chunk so that it can move forward, then I need to keep going. Let's see, so if there are stops here, Okay, so the otherwise case, if there are no U's, then I had decided not to add the current cell, but now, well, I definitely don't want to add the current cell, but I might want to add things to the chunk, depending, might want to add the current cell to the chunk, depending on whether there are things that are stopped. Like if there are things that are stopped here, then the things I was unsure about whether they should be moving or not, they are not going to be moving, right? Because there's a stop. So how do I represent that? Oh well, I already decided on a way to represent that, right? That if there are things that are stopped, then I am dropping the chunk. I'm just returning that thing, and otherwise doing something more interesting. So in this case, the more interesting thing is that I'm adding to the existing chunk. So that is just of the current cell, and we add on top of that the existing we add that to the existing chunk. So what is the criterion? Same thing as before, is push rules. Those lines are getting so long. Maybe this active cell push rule is pretty long. Maybe I can give it a name. Like current active cell can be defined as this thing. And now the line is slightly shorter. Yeah, I like that better. Okay. So I've been ignoring for a while the errors above here because I wanted to focus on the logic and not get distracted. But now I can go back and see why our thing is not compiling. Oh, it's because I changed the representation. True, that is, we are blocked is nothing. So I don't need a chunk. All right, and 94. Oh, the just or the nothing is only when I call go. I'm not returning a list of maybe chunks. I'm only receiving a maybe chunk. I'm returning regular chunks, so I don't need it just here. And 116. Move chunk, I need to pass it the little prime. And I need a base case. If this is empty, then I just return the level. Excellent, let's try it. So I was slightly worried about whether I needed to reverse the chunk. I think I would have observed the weird behavior by now if there was something odd. So now let's add the rule name is push text name. So now all the things that are text should be pushable. And no, I cannot push them. So that did not work. Oh well. I don't know why. Let's write a test. In fact, let's run the test first. Test all, I think. Yeah, test all. So do the existing tests work? Because I just changed the movement implementation, and all of those tests were hard won. Okay, you know what? Let's add text at the end, because I always forget to add it when typing cheapcid. So now I'll know the difference between the tests are hanging and the tests are passing. So the tests are passing, that's good news. Let's add another one about pushing. Maybe I can just tweak one of the existing tests. Let's see. Yeah, no, let's create a brand new test. Just push the push test. Okay, so for the push test, I will have a thing that is you and a thing that is push, and I will push. And I expect to have pushed it, and now they're both moved to the right, towards the right. So that's the simplest possible case. So Giggles is you, and P is not push. It is push, not stop. So char name P. Passed. So this does work. Okay. What if I am pushing something against an obstacle? I should not be moving. Let's separate them by an extra space so that they also look separate in the output. Oh! Oh, well, I haven't made the S stop, so of course it's moving towards the right when it shouldn't. Still not working though. Let's see. Yes, they're all piled on top of each other, which is an indication that I am running the movement in the wrong order. Although if I had been running the argument, if I had been running the movement in the wrong order, a lot other tests would have passed. So if I add back this, I already had the reverse, but if I remove the reverse, for example, now I have this other test which passes. So so now I'm pretty confused. I kind of both need reverse and not reverse. Like, let's make sure at least that if I remove this reverse, that particular test is passing by commenting out the other tests. No, it fails in both cases. Does it fail in the same way? If I have reverse here, so it was GPPS is still, oh no, it's PGPS instead of GPPS. Okay, so the reverse does make a difference, but they all end up on top of each other. Why? Oh, because it's the expected result. That's why. So yeah, in the case in which S is stop and P is push and G is U, if I try to move towards the right, I cannot push, but I can walk on top of the P. So this is what happens. And this is also what happens in Baba is You. We don't normally see it because when we say that something is push, it automatically makes that thing stop as well in Baba is You, and so you have to set to both make something push and something not stop in order to get this behavior that you can walk on top of things that are push. In my version, making something push only makes it push, it doesn't make it both push and stop. So yeah, this is the expected behavior, but it would be different if I had Giggles who was pushing on something. Yeah, instead of P, let's call it A, so that I can have multiple things that are push. So if I'm pushing on B, that is also push, but this time B is both push and stop. So, well, first of all, if I push on it, even though it is stop, it should move forward. So, oh, now I'm asking that it's not moving. That's not what I want. Let's. So the S has not moved, of course, because it's stop. And if I remove those. So let's see, I do want them to move towards the right, so it would move here. And that's not what I get. So let's go back to the drawing board. Although while I'm here, let's keep writing more tests. They're so easy to write. Wrote a nice test framework. So let's just give one more spacing. Okay, so if I have G B S, that is if same thing as the GBKs. No, the GBKs. Yeah, if something is both push and stop, the push should win. I should be able to push it. But here, if something like A is push but not stop, I should be able to walk on top of it. And so here the difference is that B is also stop. So because it is both push and stop, I'm not able to walk on top of it when it is blocked by a thing that is stop. Okay, so that is the reason I want. And finally, oh, and it seems to work. It's only the GBK that is not working. So finally, what if there is something? Well, let's just put a bunch like G, G, A, B, G. Yeah, what happens then? This is just random. Just to see if there's some case I haven't thought about. So in this case, G, G. We'll just see what I expect. G. Both G's are successfully moving towards the right. What if there's... Oh, yeah, okay, yeah, I should test this case. What if I'm pushing more than one thing? I'm pushing two A's, then they should go towards the right. So, are they well aligned? This G goes here. So it was G, A, space. And now I want them to all move towards the right, even though there's more than one. And that didn't work either. The A moved, but G didn't. That makes no sense. And maybe one last test. If I am already on top of something, so if G is on top of something that is stopped, I already made a test for that, but if it's push and stop, then I should be able to get out of here. Let's give it one more space. There you go. So it was G and B. I should be able to move out and follow here. One more space. And if I have a G on top of a B and I'm trying to push an A, like all of those the same cases basically. But when I'm on top of something, I want to be able to move out of it. So in this case, G, B, A, I want to be able to move out, the A moves to the right, and the G moves to the right. Okay, so it's all broken, and it's a tiny bit too long. I guess it's still moderately readable. We just have extra new lines. So we expected GA, and now what happened here? We didn't have a problem with that earlier, did we? Oh, we did. Okay. Okay, the A is moving as far as it can. Okay. Well, why is that? What? Well, let's tackle that first. I thought that this very first one, the GA was moving, but I guess it was only working when it was in isolation, right? When I had nothing else after it, like that, it was working fine. And what if there was just like one more space? Did the A move all the way there? Yeah, it does. Okay. So let's figure out why the things that are push are moving as far as they can. But it's probably again related to the chunking order, doesn't it? So I don't quite understand why it happened. I suspect it's maybe related to the fact that here, where? The place. Yeah, here we have an active cell with the current position, and here current active cell is also referring to the same position, P, so we'll be moving its contents twice. Not sure how that would cause this behavior, but since I was concerned about like the order in which I perform the movement, then having it done twice, I don't know, it seems like it could be problematic. So I'm thinking of generalizing move sprite 2 so that it can move more than one cell at a time. This way, the caller of move sprite 2, don't have to worry about the order in which I call that. So let's stash what I have so far and just focus on changing move sprite 2, which I guess is move sprites 2, or I guess move entities 2. Sprite was the old name. Am I referring to the word sprite anywhere else? Oh, quite a lot. Draw sprite. Find sprite. Not sure. Maybe there's a more semantic difference between entity and sprite that I somehow forgot about. I think, okay, so name is something like Giggles, so that refers to all of the occurrences of that word, either on a box that has that text, like a piece of text that I can move around in a level, or the entities which are Giggle, and entity is like a description of, okay, what is it that I'm talking about? What is it that I want to draw? Do I want to draw a box with the word Giggle on it, or do I want to draw the Giggle sprite? Whereas I think I wanted sprite to mean more specifically like one occurrence of that entity within a particular cell. So I guess if that's the name I wanted, I guess move sprites 2 is a better name. So where is that defined? Move sprite 2 is in level. Move sprite 2. So if we generalize it so that instead of taking a single entity, it takes, is that an active? Well, it's certainly a list of things. So this used to be the old position, the new position. So now it needs to be the old position, the predicate, and the new position. A bunch of triples like that. And we had a maybe level in order to prevent us from accidentally moving outside of the boundaries of the level, but we're now doing that. We're now being careful not to call move sprite 2 with movements that do that. So maybe I can fail at runtime instead of returning a more complicated type, because I know it's a contentious opinion, but I think that we should be using exceptions for things that are bugs, things that are mistakes in my code, and we should be returning values like a maybe or an either to represent the errors that actually can happen even if I did not make any mistakes. If it's like an expected error. Like I'm looking for something in a list and I don't find it. I need to remind the caller that the caller needs to deal with that case. Whereas, what would be a good example if I made a mistake? Okay, like, I thought I had an example, like binary search. Like if I have an invariant that all the elements of the list are supposed to be sorted, and while I try to do binary search, I like reach an impossible case that wait, if things are sorted, this should not happen. Then I should not be returning false and force the caller to figure out what to do if there's a bug in the code. If there's a bug in the code, the correct thing to do is to throw an exception and make the programmer fix it. Okay. So, as I was saying, I have a list of triples of the old position, a predicate indicating which of the things in that cell are moving, and what is the cell to which we are moving. And I can implement that using the / operator. I don't remember why there's a / operator. Let me see. / where's / fine? I guess slash is a special character. There you go. So it's defined in this file. So there is defined in terms of the / operator. So so the / operator takes an array and a list of pairs of changes that I want to make to the array. So pairs of positions, like indices I, into the array, and values A, or indices E, of values that I want to write at this particular position. But here, it looks like on the contrary, I am saying that at position I want to apply a function. Fine. And I do that by applying the function on the value that was there in the old array before I made the change. Okay. Fine with me. And I did that why? Because here in the source position I want to remove the things that are not movable. Oh, I already used the word movable. Because remember earlier I was unsure about the name active versus movable. Anyway. Yeah, I want to remove the things that are movable, so keep the things that are not movable, and here I want to add on top the things that have moved there. Sure. So if I now have a bunch of things that are moving away, and a bunch of things that are moving towards. I'm concerned about the case in which there's two of those entries that have the same position. Because we do now have that case, right? I have two separate chunks for the things that are U moving out and the things that are push that might or may not be moving. So I want to generalize this so that it works in that case. And I also want to change it so that it takes this new input. So instead of moving a single position, I'm now moving several. So that's the same generalization. Before there was only one cell position, so there couldn't be two. Okay, so now I need to deal with that. And I guess slash slash doesn't really deal with that either, right? So what happens if there's two different entries here that apply to the same function? Well, in the case of the regular slash slash operator, right? If there's two mutations occurring in the same position, well, one of them must win. I don't know most. I don't know if this is the right most or the left most. We should probably look it up. So it's been updated by the association with the right argument. Repeated indices are handled as for array. The resulting array is undefined, but GHT's implementation uses the last association for each index. So it is just applied associations from left to right. So if I mutate the cell and then mutate it again, then it's the second mutation whose result remains. So here, if I'm applying two functions, then I would hope that I'm applying the function, and then I'm applying the function again, and so I have the result of applying, although this could be two different functions, like if in the array it's f1 and then f2, I would expect to have the original value, f1 of that, and then f2 of f1 of the original value. But that's not what would be occurring with this implementation, because I am looking up the value in the first position, not the first position, the first array, like ES, the unmodified array. So if there was the original value, and I want f1 of the original value, if there's only one f on that position, that's what would happen. But if there's a second one, then it would be f2 not of f1 of the original value, but it would be f2 of just the original value. So that's what I'm looking up in ES here. So let's fix that. And in order to fix this, do they have a function that would fix that? I don't really see it. Well, what if we combine them? So I'm given an array. What if I convert that to a map so that I have to combine together everything that pertains to the same index? So I have ord. If I do that, I might as well be using a map instead of an array, shouldn't I? Like to store the entire level? Why use both the array and the map? I don't know, we can think about that later. So I must also have an OR instance. And then this will allow me to combine the f's. So that's going to be a map from I to ELE, where if there isn't a function in the map for a particular I, it means the identity, I don't want to touch it. And otherwise, I do want to combine all of the functions. So do I want a list of functions here? No, I can combine them as I construct the map. So map has a from list function, list, not nullity, I want the one which constructs a map, this one. But why is it not internal? Let's just look at the regular map, the one without the big red warning at the top. Oh, well, this one has no documentation. So I guess we have to keep this one. So what if k occurs more than once? The last value is u, so that's the same logic as for slash slash. But if I use from list width, then we have a combining function, a arrow a arrow a. That's the first argument, right? Yes. So compose. Now I need to be careful about the order in which I'm composing those. So from ascending, presumably, list width, build a map from instance to list in a linear time with a combining function for equal keys. So does that mean that this assumes this is ascending? No, because this 5 and then 3 and then 5 are not in ascending order. Oh, but we can use the example to figure out the order. So if we use plus plus and we have, well, A, B, A, it would be the same if it was from left to right or from right to left, so that doesn't help. But for 3, B, A from left to right, but they have A, B instead. Okay, so that tells us that it's like reversed or something. We okay. So if I have in the list F1 and then F2, and I said before that I want F2 of F1 of the result, so I think I do want dot, because dot combines F1 and F2 into a function that applies first F1 to the argument and then F2 to the result. And I said if I encounter F1, then F2, then this binary function will be applied, and that was after F2, then F1, so I'll have F2 dot F1, which is what I want. So yeah, from list with dot of ifs, list of i's and f's, and that gives me, well, I guess it's still a mapping of I and f's, but this one is in a map. It's fine. The map or map from I to f's, something like that. And now that I've done that, I can convert it back. Map of to list. IFS prime will give me back I from E to E, but now there will only be one occurrence of each, so I guess I can do that here. Map the from list of that thing to construct IFS prime, so I don't have to worry about what to name the map. And now when I use IFS, I should use IFS prime instead. What is this IS? It's the list of all. Yeah, I'm applying this function, which applies the function to the original, but now the function is the combined function, so that bug is fixed. Well, it was a bug that it was a bug in the implementation of ///, but I think /// was never called with more than one occurrence of the same position, so that was a hidden bug, I guess, that was not exposed. So now move sprites 2 can use /// in order to talk about the same position multiple times. So what do we want to do? We want to remove all of the things that are movable and then add the things that have moved to the destination. But if I do that in that order, then there will be a problem, namely that if in my list, here my input list, I have the same position twice, then I could be okay, removing the things that are movable, fine, and then adding to that cell something that has moved from somewhere else, and then because it appears twice in the list, remove the thing that was just added. So that's no good. So I think for that reason, let's see, how did they call it in slash associations, and I'll construct a list of associations that is from a position buzz to functions from an list of entity to list of entity, and I can do that by concatenating first all of the things that remove entities, so everything will be removed from the map, and then everything will be added at their target destination. So yeah, that sounds good, because the array will preserve the order in which we do that. So for each of, let's see, so do I still want to call that a movable? Not really. Especially not, no, because movable was the name for the function. Is like this function here, is an entity a boolean. Because I've changed the type, but I have not yet changed the parameters so much. So each of those, shall we call them actions or moves? And so for each move and moves, I want to do something like that filter. And well, I can now expand it out to source, movable, fine. How about is moving? Much better name. Destination. Don't care about the destination here, but I will care about it immediately afterwards. After that, I add back all of those which do move. So now it's the opposite. I don't care about the source. I do care about the destination. And I want to do this thing. I want to add on top the things that need to be moved on top. Which are those? It says entity stack. And that's something I obtained for that particular position. So maybe after all, I do not want to, I do want to use src. I think I can use like comma to have a let in the middle of this list notation. And I no longer need to guard, nor to do, because no longer returning a maybe level. So in level of that thing, or maybe like that? No. Okay, so entity stack, those are the things that are moving, and I'm looking up the things that are moving at that position in the original array, and I think that does make sense even if there's more than one positions in the list of moves, if there's duplicate positions, if there's a movement that says move all of the things that satisfy a particular predicate away, then those, it's those that were there at the beginning that I want to move, not like the result of moving on other things on top of it. It's not like if things that are moving on top satisfy this predicate, it's not those that I want to move. Okay, so excellent. Then I does this check? No, but it's just because I need to import qualified data.map as map, so I can use from list, because you know there's many functions that I call from list. I want to use the one which constructs the map. And 217. Oh, that's the current line. Couldn't match expected type list of pairs. Oh, it's to list, not from list. I already converted from a list to a map. Now I want to convert back from a map to a list. And 2, 3, 4. So that's a function. Oh, it's just I have rename is moving is moving. 2, 4, 3. I don't want those anymore. I want the SX. Oh, I haven't thought about the level list at all, because in my representation for a level, I'm storing everything twice. I'm storing every entity both somewhere on a stack in the array representation of the level, and also somewhere in a list of all of the entities. I would like to finish this stream relatively soon, so I think I'll just try and finish this part hopefully quickly. So it's not just is moving here, is it? Yeah, because I'm referring to entity stats, so it's going to be more complex than that. Let's see. So I had the level list from before. Let's call it level list prime, and do the logic here in the left. Level list prime. What is level list? What is its type? It's a list of entity and cell pos. Okay, so that's what I had. I had a list of entity and cell pos, and all of those that are moving are now elsewhere, right? So let's see. If I first do this filter thing to remove the entities, then will I know which ones to add back? Yes, I will. Yes, I will. Okay, so I can do that. Let's start with level list. And then I want to filter out the things that are moving. So now it's a bit annoying because I have a list of things that are moving and I have a list of all of the entities, and if I have to iterate through all of them, like it's going to be quadratic. But let's get it correct and then get it fast. So I guess I did another is moving predicate here, but it's a different kind of predicate. Entity moving, it's not a better name because this one is also from entity to bool. This one is if there's an entity in this. Oh, okay. This one is not from entity to bool. This one is from an entity cell pos to bool. So if is this entry moving, okay, and I can do that with an entity E and a position B. If there is any element in moves, something moves, where we have the source and is moving and the destination. So if the source is the position and P satisfies the predicate, maybe I should name this function, I don't know. Keep it in mind for now. So if any of the moves are telling me that this entity is moving, then I want to remove it from that list. That should type check. No? 252. Oh, this is like a little. I should just count it out. 247. I'm confused. Why is that not type checking? Any takes a predicate and a list. This is the list. This is the predicate. If I do give a name, then you'll get a better error message. Is this list entry moving? I guess I could put it in a where clause so that it has access to the E and the P. So this is from the cell clause, like this thing basically. To cool. I really want to be done soon, but I also want to finish on a high note. So source is moving, destination, those two things. Right? So if any is this entry. Do I indeed get a better error message? Yes, now I know that the error is inside of my definition, and like before it was pointing to moves, and that's because while Haskell is great at type inference, which means I don't have to write as many type signatures because Haskell can infer the types from what I'm typing. It also means that when I'm writing something wrong, it infers the wrong types everywhere, and so in particular, the error message might be pointing to a different place than what I consider to be the bug at. Because it thought that my definition of that inline function when it was here was correct, and that therefore the type of moves must be incorrect. So now I added it, I gave GHC more information, I gave it the type that I do expect this function to have, and it's telling me, no, that's not the type I inferred for it. So why is it not happy with that? Int with p. It's because it's not p, it's e. There you go. And there's no compilation errors in this file anymore. It's in rules, but I don't want to forget what I was doing here. I've only removed the entries that I want to remove. I now want to add a bunch more entities. So I think it's basically the same thing as this. Maybe in fact I should give it a different name. So removed and added. Right? So removed would be a list of subcars to the entities that are well, this one's fine, I think. Is it? I just want to name those two things. Removed and added, so they will both have the same type as socks. Second define them as removed plus added. And the reason I'm doing that is so that I can reuse the list of things that are added here. So if I iterate over the things that are added, so we just said it was yeah, I think it would be simpler to have this. Then in added, I do the transformation. In SX, I do the transformation for each position in entities. In added, I want to add the entities at the end. Whereas here, for each position and entities that are added, I just want to add them. So entity and position. Bit like that. Or like that. Like that. Okay, cool. Oh, and all of that is something that I'm adding to the result of removing the entries from the full list. This is taking a lot longer than I thought. 2, 3, 4. Still not done. Why not? I just moved it here. It should be the same type. Oh, I think I might have 2 nested lists. There you go. Okay, so I'm done with the changes that I wanted to make in this file, in level. I have not yet made the corresponding changes in rules, but I will do that in the next episode because this one has been long enough as it is. So thank you and see you next time.